With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, here is our question. In a series RLC circuit, if the frequency is increased to a very large value, what value does the phase angle between current and voltage approach? Okay, so here it is given that frequency is approaching to a very large value. So we can say that frequency is tending towards infinity. Okay, and we have to find here the phase angle between current and voltage. Okay, so phase angle is given here by phi, so we have to find the value of phi. Okay, now we know capacitive reactance, that is given by Xc, is equals to 1 upon omega c. Okay, now if omega is tending to infinity, then this Xt will tends to 0. Okay, and we know inductive reactance, that is given by Xl, is equals to omega into L. Okay, now frequency is tending towards infinity, then this XL will also tends towards infinity. Okay, so we can say that Xc becomes equal to 0 and XL becomes equals to infinity. Now we will find the phase angle between current and voltage by using the phasor diagram. Okay, so let me draw this phasor diagram here. Okay, now let us take the current is in the positive x-axis direction. Okay, this is the direction of current. This is the current. Okay, now we know the voltage across resistor. If resistance is equals to R, the voltage across resistor is in phase with the current. Okay, so it is the voltage across resistor which is given by VR equals to I into R. Okay, and the voltage across inductance is given by VXL. This voltage across inductance lead the current by a phase angle of pi by 2. Okay, and the voltage across capacitance, which is given by VC, this voltage lags the current by phase angle of pi by 2. Okay, now the value of VXL is given by XL into I. Okay, and we have seen that the value of XL is tending towards infinity, then the value of VXL is also tending towards infinity. Okay, now VC is given by XC into I, and the value of XC is tending towards 0, so the value of VC will also tend towards 0. Okay, so now we have to find the resultant voltage of these three voltage by considering them as vectors. Okay, so here we can see that VXL and VC are in opposite direction, and if two vectors are in opposite direction, then their resultant is given by first vector minus second vector. Okay, so VXL is infinity and VC is 0, so this value will also tend towards infinity. Okay, now we have the resultant of these two vector which will be equals to nearly VXL. Okay, now we have to find the resultant of these two perpendicular vectors, that is VXL, which is the resultant of VXL and VC. Okay, and this VR, so the resultant is given by this. Okay, this is the direction of resultant vector. Okay, it is given by VR. Let us give it by V resultant, because we already have taken the voltage across resistance as VR. Okay, so it is V resultant. Okay, now this angle is known as the phase difference. Okay, because we have current in this direction and resultant voltage in this direction, then the angle between these two is known as the phase angle. Okay, now we have tan phi. In this triangle, tan phi will be equals to perpendicular upon base. Okay, so here perpendicular is equals to VXL divided by base is equals to VR. Okay, and we have seen that the value of VXL is tending towards infinity, So this will be in infinity divided by VR, okay, and that will tend to infinity. And we know if tan theta is tending towards infinity, then we have the angle is equals to 90 degree. So here we have the value of phi is equal to 90 degree. That means the phase angle here is 90 degree. So option A is the correct answer for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.